Hello everyone. In this video, I'm going to talk about significant figures. When we are going to talk about significant figures or Sigfig, we are going to talk about one of the most important topics in our chemistry classes. Please understand the knowledge of Sigfig is not only related to the chapter of Sigfig. You need to apply the Sigfig knowledge to solve all of the problems in our chemistry class. You need to learn Sigfig in this video and apply that one for all problems we do have for the rest of the term. So please understand, whenever we are going to talk about Sigfig, we are going to talk about one of the most practical topic in the chemistry. So we are going to work on Sigfig rules and working on some examples in this video. First, I'm going to define Sigfig by giving you a couple examples. This is the definition of Sigfig. I may ask you, please read this definition and think about that. After that, I'm going to work on a couple examples to show you already knew this definition before calling that Sigfig. So, as we see here in this definition, it says minimum number of digits needed to express a measured number without losing accuracy. We are going to know what does that mean, minimum number of digits, and why do we need to apply that one on measured number, and what is the accuracy related to this definition. Before working on the definition, please remember that I did record one video to talk about measured number and what is the difference between measured number and exact number. So please work on that type of video to understand the meaning of measured numbers, and then we are going to apply Sigfigs only on measured numbers. Sigfigs only is applied on measured numbers. Let me give it you one example. Assume that we have two numbers. One number is like this, 2.05 grams. Another number is 2.051 grams. Assume that I measure mass of one object and one student gave me 2.05 as his report and another student gave me 2.051 as his report. We are going to know which number is more accurate, who is reported by more accuracy. If you are going to answer this question, I am sure all of you are going to pick the second one, B. Probably you have this definition for yourself. Accuracy means we have more digits on our measured number. If you say something like that, I don't want to say this is totally correct or totally wrong, but I'm gonna say you are right. If we are going to talk about accuracy, we are going to talk about more details. We are going to talk about some numbers reported by more digits. So if we assume that more digits, it gives us more accuracy, and we accept that one, we already knew Sigfigs. So based on the definition, it says minimum number of digits needed to express a measured numbers. So this is a measured number. This is a measured number because we have number and units. And minimum number of digits. In this number, the first number, we have 3 Sigfig. I have no idea what is a Sigfig, so let me erase that and say 3 digits. In this number, I may say 4 Sigfigs, or let me erase that one, 4 digits. So guys, you don't have any idea what is a Sigfig. You say this number reported by 3 digits, 1, 2, 3. This number reported by 4 digits, 1, 2, 3, 4. So more digits means more accuracy. If we accept that one, it means we are going to talk about something like Sigfig. So Sigfig is going to represent accuracy of your measured numbers. It depends on the number of digits we are going to have more or less accuracy, and you are going to determine who was accurate, who was not. For our class, I may ask you please memorize Sigfig rules in other slides and learn how to apply to solve your problems. First, Sigfig rule. I'm going to ask you please memorize that. You need to memorize Sigfig rules. So the first Sigfig rule is says non-zero digits they consider as Sigfigs. We are going to know what does that mean. Assume that I have this number. Assume that I have this number 2.156. 2.156. Unit is centimeter. So I'm gonna know how many significant figures are present in this number. So let me write a question. How many significant figures are present in this number? In this number. This is the one of the questions you see on your exams, on your homework assignment, and mostly whenever we have a topic related to Sigfig. So, how many significant figures are available in each number? To do that, the first rule is non-zero digits considered as Sigfigs. So, there is no zero here. All digits reported as non-zero. So I just count them 1, 2, 3, 4. I say we have 4 Sigfigs in this number. Another example I'm going to share with you 1.285963. Unit is kilograms. So we are going to know how many Sigfigs are present in this number. We just need to count all non-zero digits. There is no zeros here. 1, 2, 3, 4, 5, 6, 7. You should say we have 7 Sigfigs in this number. Or in another example, 1457, we have 4 Sigfigs here. So whenever we give you numbers, we assume that they are measured numbers, and you need to answer that one based on the Sigfig rules you already memorized. So first rule is all non-zero digits considered as Sigfigs. So it's so easy, and we can apply that one to count Sigfig rules. The second type of Sigfig rules that you need to work on when we have zeros. As you see here, we categorize zeros here by 3 different classes. I don't want to ask you to memorize terminology we have here, leading zeros, trailing zeros, or so on. I do ask you to understand the meaning of zeros and how to apply them to count Sigfigs. If we have leading zeros, in some textbook call them placeholder. Placeholder. So we are going to know where is the decimal places here, and also we are going to apply the decimal places for this. But I don't want to talk about this one. I don't want to talk about this, this, and that one. I'm going to give it you this definition by another terminology, and it helps you to understand and memorize easier. So this is the most important Sigfig rules you need to memorize. So if we have zeros, let me categorize our zeros in 3 different classes. If we have zeros at the beginning of a number, if we have zeros in the middle of the number, and if we have the zeros at the end of the number. It would be same like ABC. At the beginning of the number, it means leading zero. In the middle of the number, it means the second one. And at the end is going to be the last. If we have zeros at the beginning of the number, we call them non-Sigfig. Non-Sigfig. So this rule is going to count our zero digits as non-Sigfig. We are going to know what does that mean. Let's look at this number 0.0025. If we have zeros at the beginning of the number, we never count them as Sigfigs. So we just need to count these non-zero digits. So we do have only two Sigfigs. In other words, if we have zeros at the beginning, we skip them. We never count them as Sigfigs. If I'm going to give it you another point of view, always whenever you are going to count Sigfigs, you should start from first non-zero digit. Let me repeat that one. Whenever you are going to count Sigfigs, you just need to start from first non-zero digit. So I'm going to ask you how many Sigfig in this number. So first non-zero digit is this number. So it means you already skipped all of the zeros at the beginning. So you should say 1 and 2. So we do have two Sigfigs. So the zeros at the beginning, we don't count them as Sigfigs. The last example in this video is going to be like this one. 0.00125 grams. So as you see here, I'm gonna skip the zeros at the beginning and we count only 1, 2, 5. So our number has 3 Sigfigs. In other video, I already talked about Sigfigs and I reviewed everything. So I do ask you please watch it because I gave it you more examples. This is a short video regarding Sigfig rules. The second type of zeros, when we have zeros in the middle, like this one. Sometimes we call them sandwiched zero. Sandwich zero means zeros are placed between non-zero digits. When we have these type of zeros, we count them as Sigfig. So we assume that they are Sigfigs. So for this number, we have 4 Sigfigs. So one example is like this, 1.0, let me write like this one, 102. So for this number 1, 2, 3, this 0 we can't it as Sigfigs because it's placed between non-zero digits. So we do have 3 Sigfigs in this example. Another type of zeros when we have zeros at the end. Please understand this is the most important type of zeros in this slide, in the type of zeros, and most of the time you are asked about this type of the zeros at the end. Whenever we are going to work on zeros at the end, we divided them by two groups. When we have zeros at the end with decimal, and when we have no decimal, with decimal, no decimal, or without decimal. So look at the rules here. Trailing zeros count only if the number is written with a decimal point. If we have zeros at the end with decimal, we count them as Sigfig. We do count them as Sigfig. If we have zeros at the end when we don't have any decimal, no decimal means no Sigfig. We count them as non-Sigfigs. So it's easy to memorize. No decimal, no Sigfig. So let me give it you example. Please look here, 100. Look at this number, 100. Zeros at the end and no decimal. No decimal, no decimal, zeros at the end. Zeros at the end. No decimal. No decimal means no Sigfig. We don't count them as Sigfigs, so we call them non-Sigfig zeros. So it means we have only one Sigfig here. Look at the second one. We do have zeros at the end. But please pay attention. We have the decimal point. Whenever we have the decimal point, it means we have something extra. So we do count them as Sigfigs. So this number has three Sigfigs. We count 1, 2, 3. Please look 100 in the first example, 100 point in the second example. They represent, they report one magnitude, 100. But it depends on our writing 100 with no decimal, 100 with decimal. We do have different number of Sigfigs. So for our class, this report is more accurate because it has three Sigfigs. This report has one Sigfig. 120. This is another example. Zeros, this one and this one, they are placed at the end. After them, there is no more non-zero digits. There are zeros at the end. We do have the decimal point as well. So we count them as Sigfigs 1, 2, 3, 4. So I wanted to give it you a couple examples here. 2020. Assume that we are going to ask you regarding the Sigfigs of this number. One Sigfig, this zero in the middle, another Sigfig. This zero is at the end. Whenever at the end, we look at the decimal. There is no decimal, so we don't count it as Sigfigs. We call that three Sigfigs. And the last number is 0.001050. So whenever I'm going to ask you how many Sigfig, I'm sure you are going to answer that one. We skip the zeros at the beginning. We start to count Sigfigs from first non-zero digit. This one. Then this is in the middle. We absolutely consider that as Sigfigs. Sigfig. This zero is at the end. This zero at the end. We need to look at the decimal. We do have decimal, so we count it as Sigfigs. So we have 4 Sigfig for this number as well. I may ask you to review the Sigfig rules by other videos that I give it you to have better understanding regarding these type of rules. In other video, I did have another explanation with another point of view and some examples for each Sigfig rule. If we are going to summarize our Sigfig rules, I'm going to have this chart. If we have zero digit, if we have non-zero digits, all non-zero digits we consider as Sigfigs. Super easy. So right side of this chart is easy. If we have zero, it depends on the place of the zero at the beginning, in the middle, or at the end. If we have at the beginning, we don't count them as Sigfigs. We skip them. In the middle, we absolutely love them. We count them as Sigfig. And if we have zeros at the end, it depends on the decimal point and no decimal point. If we don't have decimal point, we never count them as Sigfigs. We count them as non-Sigfigs. And if we do have decimal point, it means we have something extra. We count them as Sigfigs. So please memorize Sigfig rules before moving forward and working on other problems in our class. So let me talk about rounding rules. This is one part of the math review or math knowledge refresher. So if whenever we are going to round our numbers, please understand we have one rule. If the digit that you are going to round, if is less than 5, you need to drop. If this digit is equal or greater than 5, you need to round up. We are going to know what does that mean. Assume that I give it you this number and I ask you to report 1.33 by 2 Sigfig, by 2 Sigfig, 2 Sigfig. Report 1.33 by 2 Sigfigs. So you just need to say 1, 2, draw a box, 1, 2, 2 Sigfig. So look at this digit. We don't need to keep this digit. We need to drop it. Whenever you are going to drop it, if it's less than 5, just drop it. So report as 1.3. If I ask you to report 1.36 by 2 Sigfig, you just need to say 1, 2. This digit is 6, is greater than 5. So if it's greater than 5, you just need to round up. So it means 1.4. So this is the rule we apply to solve our problems when we have the Sigfigs. Right now I may ask you 1.058632. Report your number by 5 Sigfigs. Report your answer by 5 Sigfig. So you just need to say 1, 2, 3, 4, 5. So we need to have 5 Sigfigs. 1, 2, 3, 4, 5. So look at this digit. You need to drop this digit and other digits after that. This digit is 3, less than 5. You just need to drop it. So we are going to report as 1.05 1.0586. So we report our number by 5 Sigfig. And lastly, I may ask you to think about these learning check questions. Question 1, it says, which answers contain 3 Sigfigs? So let me give it you a hint. Which answers? So we probably have more than one. We have more than one. So if you look at this, for the first one, we have 1, 2, 3. This 0 is at the end with decimal. We do count it as Sigfig. So 1, 2, 3, 4. We have 4 Sigfig here. For this one, how about the zeros at the beginning? We skip them. So 1, 2, 3. So we have 3 Sigfig. Let me work on the last one. 4, 7, 6, 0 at the end, no decimal, no decimal, no Sigfigs. So 1, 2, 3. So it looks the correct answer are 2 and 3. 2 and 3. I may ask you to pause the video, answer the questions, and check your answer with the next slide. B, it says all the zeros are Sigfig. In zeros at the end, we don't count them as Sigfig. So it's not the correct answer. So we eliminate that one. These zeros at the end, we do have decimal. So we count them as Sigfigs. So 2 can be the correct answer. Last one, 2.050. Zeros in the middle, we count it as Sigfigs. 0 at the end with decimal. Again, as you see here, we have this rule. 0 at the end with decimal. We count it as Sigfig. So all zeros are Sigfigs. So the correct answer are 2 and 3. And last one, it says, round this number to 3 significant figures. Look at this number is 500,000 something. So if we are going to run this by 3 Sigfigs, this digit is 6 greater than 5, we round up 535. But please understand, we cannot round 500,000 to 535. So it looks 500,000 should be reported like this one. 500,000, it cannot be rounded to 500. So we need to have zeros here. If you don't remember that, please look at your math class note to remember how to report the number by correct rounding rules. So 2 is the correct answer. And 3 is another correct answer because I reported this number by scientific notation. In other video, I already talked about scientific notation. Please watch the video to make sure you understand. You can easily convert a number like this to scientific notation. For the students, they already watched the video. They knew that if we have a number with no decimal point, we assume that decimal point here, and we move the decimal point to make a number between 1 and 10. So I write 5.35. So 1, 2, 3, 4, 5 times. So that is why we have like this. This number has 3 sigfigs, so this number has 3 sigfigs as well. So 2 and 3. It looks for this slide, all the correct answers are 2 and 3. Let me go to work on the last slide for this video. Question said, what is the correct answer if we are going to have same number of sigfigs for each pair? What does that mean? In this pair of numbers, we have 3 sigfigs, we have 4 sigfigs. So it says, which one has same number of sigfigs? 3, 4. It's not the correct answer. How about this? 1, 2, 3, 4. Zeros at the end, we consider them as sigfigs. 4. How about this? 1. Only this, not that one. No decimal. 1. How about this? Zeros at the end, forget them. No sigfigs. 2 sigfigs. How about this? These two zeros at the end, no sigfigs. So if I set zeros at the beginning, please let me correct myself. If we have zeros at the beginning, forget them. No sigfig. If we have zeros at the end, no decimal point, we don't count them as sigfigs. Only 2 sigfigs here. So 2 sigfigs, 2 sigfigs. So the correct answer is this one. Thank you for watching this video. Please watch another video for Sigfig that I reviewed by a bit more examples over there.